Behavior of waves. If you've ever hollered in a long hallway, a tunnel, or even in a large empty gymnasium, you may hear your echo. An echo is caused in the same way you see yourself in a mirror. Reflections. Reflections occur when a wave strikes an object and bounces off of it. All types of waves, including sound, water, and light waves, can be reflected. So how does it work? Well, a reflection in the mirror happens in two steps. First, light strikes off your face and then bounces off. Then the light reflected off your face strikes the mirror and it's reflected into your eyes. Well, a similar thing happens to sound waves when you create an echo. Sound waves form from your voice and travel through the air, hitting another object, then reflecting off the object and coming back to your ears. Now look at this image here. If the flashlight is your source and it sends a beam striking the mirror, this is called the incident beam. The beam that bounces off the mirror is called the reflected beam. And then the line drawn perpendicular to the surface of the mirror is called the normal. Now the angle formed by the incident beam and the normal is the angle of incidence, labeled I, like the letter I. Now the angle formed by the reflected beam and the normal is the angle of reflection, which is labeled R. And according to the law of reflection, the angle of incidence is always equal to the angle of reflection, and all reflected waves obey this law. Look at this image of a pencil in a glass of water. The pencil looks like it's broken at the surface of the water because of something called refraction. Remember that a wave's speed depends on the medium it is moving through. When a wave passes from one medium to another, such as when light wave passes from air to water, it changes speed. If the wave is traveling at an angle, when it passes from one medium to another, it changes direction or bends as it changes speed. Refraction is the bending of a wave caused by a change in its speed as it moves from one medium to another. The greater the change in the speed, the more the wave bends. We know that when waves strike objects, several things can happen. The waves can bounce off or be reflected, and if the object is transparent, light waves can be refracted as they pass through it. Sometimes the waves may both be reflected and refracted. If you look into a glass window, sometimes you see reflection in the window as well as the objects behind it. Light is passing through the window and it is also being reflected at its surface. Waves can also behave in another way when they strike an object. The waves can actually bend around the object, such as ocean waves around a large rock. When an object causes a wave to change direction and bend, this is called diffraction. Diffraction and refraction both cause waves to bend. However, the difference is that refraction occurs when waves pass through an object, while diffraction occurs when waves pass around an object. Now imagine two waves traveling toward each other on a long rope. What do you think will happen when the two waves meet? Well, if you want a friend to do this experiment with you, each of you need to grab the ends of the ropes and get each of you wave your hands up and down to try to get the waves to go towards each other. When you do this, you will find that the two waves pass right through each other and each wave continues to travel in its original direction. However, if you were able to look closely at the waves when they meet each other, you will see that the waves look different than either of the two original waves. When the two waves arrive at the same place at the same time, they combine to form a new wave. When two or more waves overlap and combine to form a new wave, the process is called interference. This new wave exists only when the two original waves continue to overlap. The two ways that the waves combine can be called constructive interference or destructive interference. In constructive interference, the waves add together. This happens when the crests of two or more transverse waves arrive at the same place at the same time and overlap, and the amplitude of the new wave is equal to the sum of the amplitudes of the original waves. In destructive interference, the waves subtract from each other as they overlap. This happens when the crest of one transverse wave meets the trough of another transverse wave. The amplitude of the new wave is the difference between the amplitudes of the original waves that overlapped. Now, in compressional waves, constructive interference occurs when two compression waves overlap. Like in a sound wave, you will produce a louder sound. Destructive interference in compression waves will cause a decrease in loudness when compression and rarefaction is combined. Okay, it is now time to show what you know.